11.6, geometric probability. Okay, before we go too much into it, there's just a couple terms we need to talk about. First one is just probability. Okay, probability, it's a number from 0 to 1 that represents the chance that something's going to happen. So if it's a number from 0 to 1, is 2/3 an okay fraction for a probability? Yeah, isn't that between 0 and 1? Yeah. What about 1/2? Yeah. What's 2/3 as a decimal? Yes. With a vinculum on top. So it's if you rounded it, it's 0.667, right? The repetin would be 6. The repetin is 6. It's what? No, the repetin is what is being repeated.
The repetin is 6.
We
I looked in my book and it said the repetin would have been 6.
Yes.
But, I always thought it was.
I know. Yeah, the repetin is 6. The number over the top is called a vinculum.
They're both the same thing.
No, actually they're very different.
I don't think so.
Okay. So a number and a line are the same thing.
Okay, but listen.
No, you listen.
It means it's going out, so you know what I'm saying?
No, are you doing the chicken dance?
No.
Okay. 1/2 is 0.5 is, what is a percent? 50%. 0.667 is, okay, approximately, right? Obviously that's rounded. We know that that repeats. Now, the way we are going to give our probability is we are going to give our answers as a percent. Because we know what that means to us. Okay, if I say something's 83%, you have a general idea of about how much that is, right? Okay, so we're going to give ours as a percent. The other term is geometric probability. Geometric probability, it's the same stuff, except referring to like length and area and geometric ideas like that. Okay, maybe volume. Not right now for us, but volume possibly. Thank you. Okay. So, the biggest thing with probability, and not just geometric probability, but all probability, is that to find the probability of something, you have to set up this fraction, right? Because up here we started with a fraction. Okay, we have to be able to set up our fraction. And at times it's really easy, and at times it's really difficult. You have to understand what you're doing. So the way I always like to think about probability is it's what you want or in most of your problems today it's going to be the blue shaded region. Okay, but it's what you want, okay, like if you're throwing a dart, what you want to hit divided by what you have. Or your total. Okay, so if I was talking about like a dartboard and I want to know what's the probability of getting a bullseye, what I want is the bullseye, right? What I have is the whole dartboard. So you'd find the area of the bullseye and you divide it by the area of the entire dartboard. Okay? And that would be the probability that you got or hit a bullseye. Okay, one real quick problem here. If there's a number line from 0 to 10, and I just want to bring this up because there has been some confusion on exactly what this looks like. Let's say I have a segment here, RT. I want to know, kind of crooked, I want to know what's the probability that if I walk up here, maybe blindfold or shut my eyes, whatever, and touch a point on this line, what is the probability that it ends up on segment RT? Okay, and sometimes it's easy to look at and get, but we're getting different answers. Okay, this is where it gets challenging. Jacob, what do you think? Okay, I've heard that from a few people. I've heard 30% or 3/10, and I've also heard 20% or 2/10. We got to decide which one is it. Well, where I start is right here, right? Now, when I put my marker down, do I count that as 1? If I'm standing here and I'm saying, okay, how many feet is it to the wall? Do I go 1, 2, 3? No, that doesn't make any sense, does it? Okay, so when I put my marker down, that's not 1, right? This is 1. This is 2. So it's actually 2 out of 10. Okay, that's another thing. Last class, somebody said 11. Again, when I'm counting this, that doesn't count, does it? No, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's only 10 units. You're counting your spaces, not your marks. Okay, so just be careful. You have a handful of problems like that today. So it's 2 out of 10, which is 1/5, which as a decimal is 0.2, which as a percent is 20%. Good. And on your homework, you just need to write this answer. Hey, I'm just writing the other one so we understand, because you're going to see it in different forms at different times. Not maybe just here today, but in the rest of your life, you might see percents or probability expressed in different ways. Okay, we okay here? Okay, I got 2 other examples I want to take a look at. The next one is like what I talked to you about with this dartboard. Okay, we have a dartboard. I'm not going to put all the circles in here, but I have, let's just say I have 2 of them. The radius of the bullseye is 2. The radius of the second ring is 4. This is 16 by 16. I want to try to find what is the probability that I get this bullseye that I'm looking for. So everybody wants a bullseye, right? What is the probability that I can get that? The last one was length, correct? This one's now area. What do I have to find? First of all, I want a bullseye, so that's this, right? How do I find my probability? Okay, so I find the area of the square, which is 256. Okay, so the area of my square is 256. The area of the little circle, which is 4 pi. So the area of my circle is 4 pi. Okay, so now I have 2 areas. Okay, set up a fraction, but how do I know which one goes on top, Travis? Okay, because that's what I want, right? Not just necessarily because it's smaller, which it'll have to be smaller, because my number does have to be between 0 and 1. But I want the area of this circle on top, because that's what I want, right? That's where I want to hit. That's what I'm looking for. So on top I have 4 pi, and I need to divide that over by what I have, which is my total, correct? Which in this case is 256. And we want to express that as a percent now, and I get what? Thanks, Braden. You could if you wanted to, but there's not necessarily any reason to. You can just plug that straight into your calculator. And what do I get as a decimal? So as a decimal, you get 0.0491, right? As a percent, Royal tells me I move that 2 places, I get 4.9%. Which makes sense when you think about a dartboard, because the bullseye is not very big, right? Okay, and on a real dartboard, it might actually be a less percent than that even. Now, does my geometric probability change if I'm really good at darts? No. Now, there's a thing called actual probability and there's theoretical probability. There's different types of probability. But our geometric probability isn't going to change just because Taylor's really good at darts, right? Or whoever. The probability of hitting that spot is still the same, talking area. Okay? Now, if we threw Taylor's percentage up here, and maybe he hits a bullseye 6 out of 10 times, and I hit a bullseye 3 out of 10 times, obviously there's probably a better chance that Taylor hits it than me, right? Okay? But does that change my geometric probability? No. Because it doesn't change the dartboard, does it? No. The dartboard's staying the same no matter what. Okay. The other problem I want to take a look at before we get started on your homework is like the problem we did the other day. Everybody remember this problem? Okay. I'm going to give us a bunch of information here so we don't have to actually go through and find the area of the hexagon. Okay, so I'm going to give us excess information, more than what the book is going to give you today. I want to know what's the probability that I hit the blue shaded region. Okay, I'm going to tell you that the area of your hexagon is 300 square inches. And the radius is, let's just make it fairly easy, 10. That should work out. No, that's not going to work out. Let's just say that this is 30 inches squared. And then the radius is 10. Okay, again, I'm just making this up, so hopefully this works out. When I set up my probability, what goes on top? It's what I want. So what I want is this blue, right? How do I find that? Other way around, but yes. Take the circle and subtract the area of the hexagon, right? Okay, that's what we did previously, on the previous lesson. We have to use that first. Okay, so let's do that. What is the area of the circle? 100 pi. Okay, so that's the area of the circle. But to find the area of the blue, I need to subtract 30. Okay, so 100 pi minus 30 on your calculator gives me what? You don't need to write all your decimals out. Okay, maybe 159 if you're going to go any further. Okay, if you want to do that, if you want to go 159, just to make sure your rounding isn't messing you up. You don't need, was that all the decimals on there, was those 4? Oh, it wasn't? Okay. I see what you're doing then. Okay, that right there is the area of what? The shaded region. Is that what I want? Yes. Didn't I ask for the probability of the shaded region? We just found the shaded region, right? So that's what I want. So that goes where? That goes on top. What goes on the bottom? The area of the whole thing, which in this case is a circle, which we found to be 100 pi. And now I can just divide those. So I have 284.159 divided by 100 pi. 0.7899, which as a percent is 78.99%. Sorry? What? Yeah, I did use parentheses. Did you? Oh, I did 248, not 284. Thank you. 0.9055. So it's actually 90.55%. Okay, did anybody forget to use parentheses?
How'd you get the 5.5? I got 0.9045.
I got 0.9054. 6.
Okay, so I took 284, 16, divided by 100, and then I put the pi in parentheses.
No. 100 pi has to be in parentheses.
Oh, just the whole thing.
Yeah, because you want to multiply those first. Because the whole 100 pi is on the bottom. So it needs to be in parentheses. Okay? So just be careful. The problem you're going to have is a square inscribed inside a circle, but you have to be careful. Understand what you're trying to get. It's what you want, which may take a little work to get, divided by what you have total.
Excuse the interruption, Mr. Stoney.
Yes.
I need Ryan McKnight down to the office, please.
Okay.
Here.
Where did you get 5.5? I'm so
My calculator says 0.90546.
Mine says 0.9045.
That's because you rounded 248.16. I did 248.159.
I did 159 too, yeah, so do I. Your calculator is wrong.
It's because I did 459. I typed in the wrong, but I hit the wrong number again. But that would only change you 1/10 of a percent,
Would you,
or 100th of a percent.
let's say I put like 0.16, would you have it wrong still?
This is 0.16. Question. That's a question. Is that 0.16? Yeah, it should be. I accidentally hit a 4.
No, at the top. No, at the top. The 284.1.
What did you get for your final answer?
Can you just
Stop. No.
90.5.
90.5. That's what I got.
Okay. I was just confused for the next slide, you know?
Yes.
I got 0.906.
It's basically the same thing.
Basically,
You're less than 1/10 off.
yeah.
Okay. Yes.
I'm confused on how that 284.159.
I had to find the area of my blue. Okay. So I had to find the area of the whole circle, and then I had to subtract the area of my hexagon. Because once I take that hexagon out, I'm left with just this blue part. That's what goes on top. That's what we ended up with here. I gave you the area of the hexagon. You had to take the area of the circle, subtract that, and that's what went on top. And then on the bottom was the whole diagram, which was 100 pi. Okay, I can help you some more in a second if you need it, okay? Okay, yeah, if you're within 1/10, it's the same thing. I'm not going to count it wrong if you're within 1/10, probably 2 to 3/10. Okay, but you need to be close. Take your time on your homework. It's easy to make a small mistake here. So take your time. We've seen how small mistakes can turn into big mistakes.